All right, so let's go over this. What are the new coordinates of the point 4, 5? And on this one, I have a little trick for you guys. I already told you what to do. Especially if you if you watch the video as a review that I uploaded last time, it was about this that you can do it numerically. Well, I have this little trick that you can use. That's my x and y coordinate, right? And then it says after being translated 2 units to the left. What does that mean? I'm subtracting from what? From the x. I'm not from the negative or positive. I'm subtracting because saying to the left from the x value. Because which one goes left and right? The x-axis, right? Which one goes up and down? The y. So if I'm going to the left, I'm going to the negatives. That means I'm going to subtract 2 units from the x, right? And then it says, and 3 units up. What am I doing? I'm adding 3 to which one? The y value, right? Because that's the one that goes up. And watch what happens. 4 minus 2 is 2. And then that would be 8. And now you get your new 2 coordinates. That's simple, right? That you can do that with every translation, meaning you're going up and down. It tells you exactly what to do. I'm sorry? The comma. I'm doing 4 minus, minus 2 and then 5 plus 3. And then I put them right here at the bottom. What? Okay. So these are the commands right there. I don't want you to use the comma for anything. I don't want you to get confused because I think you add more stuff to it and you're going away from the idea of look at these things. Go ahead. No, the 2 just means you're going 2 units to the left. Yeah, so that's why I put -2. Because if you're going to the left, you're subtracting from the x value. If you're going to the right, I would have put +2. On this one, it says go 3 units up. So I'm adding to the y value, right? Because the one that goes up and down, so I put plus. But if it was going 3 units down, I'll put -3. And then I'm basically, I separate these two and like 4 minus 2, it gives me 2. 5 plus 3, it gives me 8. So this is my new coordinate. Get it? I just heard the comment. I was like, I don't want you to think of that as it has anything to do with anything because it doesn't. That's just separating the y and the x. Okay, number 2. This one is reflecting. On this one, I also have another thing that you can do. So you do 3 and 5. This is my x and this is my y value. So watch what I do. It says, after we've reflected across the x-axis, I told you that when you reflect across one, the other values change, right? So what I do, if it's saying x, I'm going to circle the x as in I cannot touch that number. I have to protect it. But I underline the y because the y has to change sign, whatever it is. If it's negative, it becomes positive. If it's positive, it becomes negative. So I rewrite it as 3 and +5, and these are my new coordinates. That's it. But I want you to use that method of circling. You see what I circle right here? I have to circle the same axis. And that tells me I cannot touch this guy. I have to leave it alone. And then I have to change the sign on the other one. So it'll be this one right here. How many of you got that one right? Oh, great. How about number 1? Perfect. Good. All right. So for the next one, it says the vertices of the triangle are at -3 and 1, 3 and 3, and 2 and -2. This one, there was something wrong with one of the answers. It wasn't confusing. It's just that probably you found the answer and you cannot find it in the options. It's stupid. I don't know why they did that. But let's go over here and find the coordinates. So we know that this is -3 and 1. And then this is 3 and 3. And this is this is 2 and -2. And you could have translated it by visually doing it. So when I says go 5 units up, I usually raise my hand up and then 3 to the left, and I know that I have to land on the second quadrant, right? Visually. And you can also do it numerically. So when I do it that way, when I do my hands, I do it on the paper too with my finger. That gives me an idea of where my picture is supposed to land. So I'm gonna count just up 5, 1, 2, 3, 4, 5, 1, 2, 3. There you go. That's the new coordinate, and then this one is 1, 2, 3, 4, 5, 2, 3 right here, and then 1, 2, 3, 4, 5, 1, 2, 3 right there. So those are my new coordinates, and my new figure should be right there. There we go. Now, I'm going to find the new coordinates for that. This is -6 and 6. This is 0 and 8. And this guy is -1 and 3. Can somebody open the door? It's too hot in here. I don't know why they closed it. Thank you. I just got it. It's fine. All right. So all you have to do is match them with this. You can right off the bat, what's it called? You can eliminate 8 because it starts with +6, and we don't have that. The other one, the 3 go well, but then this one, letter B, it has a -8, and we know it's +8. And then you end up with the last 2. By the way, on this one, it was supposed to be backwards, 3 and -1, and I don't know why I did it that way. So this is wrong. The answer should have been C.
What if they didn't answer that?
Do what?
What if the person didn't answer that question?
Well, that's fine, because I understand the complication. For this one, you could have also used the adding and subtracting. So I'm going to allow you to do this on your own. Just write it over here, -3 and 1. And then we are adding 5 to the y, right, because it's going up. And then we are subtracting 3. And that's going to give you the new coordinate for that. So go ahead and do that one, and I'll write the other ones too. And the same thing gets done to all 3 of them. And I know this is not your paper. What you should be working on your own paper, right?
Yeah.
Okay, good. +5 -3. And that should give you the new coordinates for this numerically.
Okay.
All right.
I thought you meant like I.
So for this one, this should give me 6 and -6, right? We have it. It's right here. And this should give me 0 and 8. We have it. It's right here. And this should give me -1 and 3. And it's right here. Oh, wait a minute. I did it backwards again. I don't know why. What's wrong with me? -1 and 3. Okay. I rewrote what I already had there. All right. How about the next one? We're just reflecting, right? So you should have had the point. Like these guys don't move; they stay there because they're actually on the axis. So where are you gonna go if you're already on the axis? This one is 4 away, so you count 4 to the bottom. This one is also 4 away, so you count 4 to the bottom, and this one is 5. So when you connect them, you get this guy right here like that. Yes. It's an irregular pentagon because the sides are not equal.
It's like the house on top of a river or something.
Yeah, exactly like it. And now I highlighted the x-axis to remind you that you're crossing the axis. And now the new vertex will be 0 and 0 for the origin. And this is, no, 4 and 0, right? Because you're still finding the x. And then this would be 0 and -4. And this is -5. Nope, 3 and -5. 3 and -5. And this last one is 4 and what? Negative 4. 2? Where? Oh, I'm sorry. Okay, so you could very easily eliminate these things. I want you to look at the reflection. Um, do we have any positive, any negative x's? Any negative x values? We don't, because if you notice, all the points are from the origin to the right, meaning all the x's are positive. You can automatically eliminate basically all of them by that. This one has negative x, so that's not it. That one has a negative x, that's not it. That one has a negative x, so that's not it. It was very easy. If you know all your x values are going to be positive, then you know that it cannot have any negative x's. Do we have any questions on this? If you do, please ask me so I can address them. Most likely somebody else has the same questions. Yes. No, that's only when you multiply or divide. When you add or subtract, how many boys, what do you have, boys or girls there? 3 boys. And then at the bottom, are those boys or girls? 6 boys, right? What does that mean? 2, 3 boys, right? So you have 6 boys, which means they're all negative, right? That's where you get negative 6. Negative 3 and negative 3, you're just adding more negatives. Yeah. And the one on top, you have 1 girl on top, and then 5 girls. That gives you 6 girls, right? And because the girls are all positive. Same thing right here. You have 3 girls and 3 boys. When they pair up, nobody's left alone. Yes. And at the bottom, you have 2 girls and 3 boys. So 1 boy ends up alone. Yes. But what I'm trying to emphasize that if the girl-boy situation helps you a lot more, use it. Instead of saying 3 minus 3, negative 3 minus 3, what is that? If you're not very good with that, use the boy-girl. Yes, Tawari. Which ones are negative? The y's, right? And I told you that if you reflect across the x, the y would change, right? So right here, all the values were positive. Positive, positive, right? Yeah? That's the problem. Okay, so and this is a plotting problem. For those of you who are not very good at plotting, to find this number right here, you have to go on the x first and then the y. Yes, you crawl and you walk. So you start from the origin and then you go to the point on the x where you can find it. So right here, right? What number is that? 4. That's my x. And then I have to go down 4, and that you end up over here, a negative 4, right? But you always start with the positive. Right here is just 0, 0. I'm sorry? Which one? The y's are negative. We need to work on plotting points a little more. Because if that confuses you, that means you're not very good at plotting yet. So practice on those things. My advice would be to find the x first. Go to the x and see where it is, and then down or up depending on where the point is. And you can use that by, you can practice that by going through all these right here. No, but just these right here and the other ones that I gave you. All right. Any more questions? Okay, so this one goes with this, and that one goes with that. So for this one, it says, on the coordinate plane A, reflect triangle JLKL across the y-axis. So I'm going to go over here, and I'm like, this is the y-axis. I have to cross that. Cross the y-axis. Name the image triangle JKL prime. Write the coordinates of the reflection. So for these, you will get, if you're reflecting, just count the distance from the axis to the point, right? 1, 2, 3. So it must be 3 over here too. That's K prime. This is 8, so it must be 8 over here. This is L prime. And this is 8 as well. So it should be right here. J prime. And there you go. Now you have your new triangle. And the coordinates will be the following. This is 8 and 9. This would be 8 and 1. The x is first, remember that. And this is 3 on the x and 1 up. There you go. Always start with the x and then go up and down to find the point. For the next one, you're reflecting it across the x-axis. So you're reflecting it across this guy right here. And again, you count the distance from the axis. So K is 1 away, so it should be 1 away over here, K prime. And then L is 1 away, so it should be over there, L prime. And this is 9 away, so it should be 9 prime. Not 9 prime, J prime. And now we connect those little dots. There we go. And the coordinates for that would be -8 and -9. And this would be -8 and -1. And this would be -3 and -1. Good. All right. Do we have any questions on those? These are pretty easy. For the next part, blah, 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 we're going to do it on here. So all you have to do is tell me what kind of transformation happened. So what happened for the first one? For what? Oh, we're not there. Probably. This is it, right? Oh, okay, I see. So this one is being translated for this one. You have to go 8 units left and 3 down. So you go 1, 2, 3, 4, 5, 6, 7, 8, and then 3 down. Right here. This is 8. Oh, you have to call this X, Y, Z. So X, and then go to B. 1, 2, 3, 4, 5, 6, 7, 8, 2, 3. And this is B prime. 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3. And this is Z prime, just Z, and this is Y. X, Y, Z. And now you have your new figure. So this would be -6 and 5. This one would be -1. No, it's just 0 and no, what am I saying? It is -1 because the x comes first, and then 0 on the y. You didn't go up or down. And then this is -6 and -2. All right, did y'all get it right? Good. The next one, you have to go 8 units down and 3 to the right. So I'll start with 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. Right there, right? And this is x. And then B, 1, 2, 3, 6, 7, 8. 1, 2, 3. This is y. And then 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. This is z. This would be 5 and 0 on the y. This would be 10 and -5. 5. And then this would be 5 and -7. There you go. Easy breezy. All right, this one right here, all you have to do is describe what happened, right? So what happened in the first one? Translation. What kind? What happened? I'm sorry? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. Always do 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 units to the right. That's all you needed to do. Oh yeah, you can find the coordinates for each pair. Well, you need it. The what? And the near ones? Good.
Yeah, that's what I just do.
Oh, it does says write the name and coordinates of each pair. So you have to do that. All right, you did. So if you didn't do it, you can do it later. For this one, the new coordinates would be 5 and -2. This would be 7 and -7. And this would be 1 and -7. C is a little bit off, so it'd be a little more than 7. All right, and then the next one. What happened? Reflection across where? The y-axis, right? You reflected across this guy. And then you will need the coordinates for that too. Well, what happens if this shape was exactly the same? Let's say it was an equilateral triangle, and it was on this side. How would you know if it was a reflection or translation? How would you know? How can you prove me that it was a translation and not a reflection, or the other way around? You what? What about them? So, like, for example, A and C are right here. So if you reflect it, it will be C and A, right? And because they're in the same spot, in the same order, that means it was just translated. You will see that, I promise you. You will see a figure that looks exactly the same, and it looks like it's reflected, but actually just translated. The next one, what happened here? Translation. Across where? Across the y-axis. And the other one? What? Reflection. Across the x-axis. All right, for just letting you know ahead of time, for your homework, you will have to get the coordinates of each. If you already have it, that's fine. However, here's what I want you to do. Just to verify it, get the coordinates of these and then add or subtract or do whatever you need to do so I can see it numerically on the sides. So for example, this one says you're going to move it up, right? That means you have to add 9 units to every x value, right? And the other one stays the same. You don't add anything. You go back to the video to where we added and subtracted. Yes. We're not done yet. Yeah, more. I know. The what? No. Okay, this is easy. We don't have. We have like 7 minutes. All right. So for this one, these were very easy, right? Just identify what was happening. So what is the first one? And then for this one? Two. So notice how these two look the same, but the dot is on the opposite side? That's what I was talking about. You need to be able to verify that. Yes. Right? What happened? I'm just writing it this way for the sake. The what? Yeah. From here to here, it was a translation. From here to here, it was a. From here to here to. No. They give you an example. All right. Number 4. I'm gonna give you a few more of these. Are cool. This one, the bottom one, and this one right here, number 5, number 6, I mean 7. Y'all sound like you know everything. Lies. Okay, so on this one we had a problem. Some of you did not understand. So I'm gonna show you what we just did it for the homework. So where is the figure? In which quadrant? The third, right? So I'm gonna highlight the quadrant that it's in, and then it's saying rotate 90 degrees clockwise. This is right. So it's gonna land right here, right? And just identify the points. So if it's 2 away from the bottom, from the this one right here, then he has, 1 away, so he has to land the same position, 2 and 1, right? The other one is 1 and 2, like right here. And then the other one is 3 and 3. That should be easy, right there. It should have landed right over there. You want to count how many units it's away from either axis. So this one is 2 away, so it should be 2 away right here. This one is 1 away, so it should be 1 away from here. This one is 3 away, it should be 3 away from that. So you can use this axis or this axis to help you. It doesn't matter. I'm sorry? Yes, it does. If I were to grab a circle, I can't take it over there. I think I deleted it. Well, I showed it to you last time already. Yeah. So for the next one, you're rotating 90 degrees counterclockwise. So you do the same thing. That means you have to land over here, right? So if this is 2 away, it has to be 2 away from here. Right there. And this is 2 away from 3, 2 away from 3. And this is right here. No, right here. This is right there. So when you connect it, you get, there you go. The next one, 180 degrees about the origin. Doesn't matter which direction. No, because you'll land in the same spot. In the opposite spot no matter what. So you have to land over here, right? So if this is 1, then it has to be 1 over here. If this is to 1 from 4, then it has to be 1 from 4. Yes. I did. Okay. All right, so when we rotate this one, 5, see from 5 right here. So we end up with this guy right here, right there, and right there. Number 4, you're rotating clockwise about the origin. So if you're right here, you must end up right here, right? This is 1 away from 2, 1 away from 6, 3 away from 2, and 3 away from 4. Remember that he has to turn every time, like if you were marching. And this last 2 is clockwise about the origin, so it should land right here. So this is on 1 and 3, they just stay on it. These are 2, and this is 1 right here from 4. There we go. And then the last one is clockwise as well. What am I doing? That looks awful. Go away. There it goes. What is it doing? I know. So, should be right here. Should be right there. 4 and 4. There you go. And you won't have any extra homework other than what I already told you to find the coordinates.
So,
You're welcome.